Let's start with a big question. What if we've been talking about climate change all wrong? We hear all these terms, right? Pollution, carbon footprints, saving the planet. But what if the real issue at the heart of it all is actually much, much simpler?
You see, at its core, this isn't really a pollution problem in the way we usually think about it. It's a straight-up physics problem. It's a disruption in the Earth's most basic energy budget. So let's break down what that actually means.
Okay, so before we can get into what's gone wrong, we first have to understand what it looks like when things are going right. For thousands and thousands of years, our planet has kept this incredible balance, a really simple system of energy in and energy out.
I want you to think about it like a bank account for the planet. On one side, you've got your deposits. That's energy coming in from the sun. It warms up the land, the oceans, the air. And on the other side, you have your withdrawals. That's heat radiating back out into space, which cools the planet down.
Now, when the in equals the out, the budget is balanced. The planet's temperature stays pretty stable. This perfect balance is what scientists call climate equilibrium. It's the natural, healthy state of our world. It's Earth's happy place.
So what keeps this balance so perfect? Well, it turns out our atmosphere has this amazing natural heat blanket. And honestly, it's the reason life can even exist here.
Here's how that blanket works. The sun's energy comes in and warms the planet. Simple enough. Then, the warm Earth tries to send that heat back out into space. But, and this is the key part, some gases in our atmosphere, like carbon dioxide and methane, trap a little bit of that outgoing heat, just enough to keep Earth at this cozy, livable temperature. Without this natural greenhouse effect, our planet would just be a frozen rock.
And for a very, very long time, this system was in this beautiful, delicate balance. But then, well, we came along, and we started to change a really crucial part of the equation. We started to thicken that natural heat blanket.
How do we do that? By pumping just huge amounts of extra greenhouse gases into the atmosphere. Every time we burn fossil fuels like coal, oil, and gas, we release more carbon dioxide. Our farming systems release methane. Other industrial processes add even more stuff. We're essentially just adding extra layers to that blanket, day in and day out.
The consequence is pretty simple, really. With a thicker blanket trapping more heat, less energy can escape back out to space. So that perfect energy budget we talked about, it's not balanced anymore. For the first time in modern human history, the energy coming in is greater than the energy going out.
It's a basic question, and it's pure physics. If you keep adding more energy to any system than you allow to leave, what has to happen? What's the only possible outcome?
It has to get warmer. The rising temperature isn't some weird side effect. It's the planet's direct physical response to having too much energy. It's the whole system trying to heat up enough to force that extra energy out and find a new, hotter balance. The warming is the balancing act. So where is all this trapped energy, all this extra heat, actually going? The answer might not be what you think. It's not just about the air around us getting a little warmer. Take a look at this. The vast, vast majority of that extra heat, we're talking over 90% of it, has been soaked up by the oceans. They're acting like a giant heat sponge. A smaller chunk of energy goes into melting ice, and only a tiny fraction is left to warm the atmosphere. This is so important. It means the oceans are absolutely central to this whole story.
And once you throw that fundamental energy balance off, everything else starts to change. This is where all those ripple effects come in, the things we usually think of as the impacts of climate change.
This quote here, it just nails it. Everything, more extreme weather, melting glaciers, rising sea levels, all of it is a direct result of this one central problem, a fundamental shift in the planet's energy balance. And to make things just a little more complicated, the warming itself can kick off other processes that actually speed things up. For example, when bright white ice melts, it uncovers the dark ocean beneath it. White surfaces reflect sunlight, but dark surfaces absorb it. So less ice means more heat gets absorbed, which means more ice melts. It's a classic feedback loop that just amplifies the whole problem.
So if you only remember one thing from all of this, let it be this. We're adding greenhouse gases, which are trapping more heat. This creates an energy imbalance that is forcing the entire planet to warm up. That's it. That's the whole story in one sentence.
You know, the planet isn't being mean or malicious. It's just following the laws of physics. It's trying to do what it has always done, balance its energy budget. The only difference now is that we stepped in and completely changed the rules of the game.
But here's the powerful thing. Once you see the problem as a simple physical imbalance, the solution becomes crystal clear. If the blanket is too thick, we have to stop adding more layers to it. We have to let that energy budget get back into balance. The physics is undeniable. So now that we understand the real rules of the game, what's our next move?